first, but that does need to happen. What's first? Expand. I like it. So, can't we make this ln of 1 minus ln of e to the 1/2? Why did I do that for? A radical is, a square root is the same thing as the 1/2 power. And why did I do that? Well, because it depends how you look at it. You could bring it down and say that ln of e just reduces to be 1. Or you could say, wait, hold on, ln is a log base e, so a log base e of e, everything gets undone except for the 1/2. So whether you bring it down and make ln of e 1, whether you leave it up and undo e with the ln to make 1/2, either way you get 1/2. Oh, but ln of 1, that one's hard. ln is log base e. How on earth can I rewrite 1 to be a power of e? Oh. What's another way of writing 1? E to the 0. What's always a way of rewriting 1? The base to the 0, whatever the base may be. So question real quick, what would be log base 2 of 1? Why? Because isn't that just log base 2 of 2 to the 0? What would be log base 17 of 1? Wouldn't that just be 17 to the 0? Why am I rewriting this? Because kiddos, what's this answer going to be? 0. Log base e of e, remember, ln of e undoes and 0 is left over. What's this guy going to be? 0. Why? Because 0. What's this guy going to be? 0. Why? Because 0. Oh, that's right! All logarithms go through the all logarithms go through the x-axis at 1, aka y is always 0 when x is always 1. Any log of 1 is 0. And so my final answer is just -1/2. So when you plugged it in your calculator, you should have had -0.5, but no calculator was necessary. Questions? What's any log of 1? So what's ln of 1? So what's log base pi of 1? What's log base 572 of 1? Any log of 1 is 0. So what's any log of 0? We're thinking. I've heard 1, I've heard 0, I've heard base, I've heard... Can I ever write a base to a power to get 0? Because a base to 0 is 1. Well, that's not 0. A base to a positive number is bigger. A base to a negative number is smaller. But how do you get 0? You can't, because doesn't it... Oh, wait. Doesn't logarithms? Doesn't it get closer and closer and closer and closer and closer to, but never hit? So what happens if you plug in 0? Undefined. Get out your calculator and prove it to yourself. What's ln of 0? What's log of 0? Go to your math menu and make a weird log base of 0. What happens anytime you plug in a 0 to a log? Error. Why? Because it's the vertical asymptote. The 0 of a logarithm is the vertical asymptote. Wait a minute! Wait. We talked about logs way back here, right? We talked about logs way back here. Find it in your notes. Go back. Section 3.2. I didn't even realize until just now we totally ignored our domain problem. If I were you, grab out a highlighter, grab out a colored pen. This is important, everybody. Now that we're seeing logarithms, we have to realize there's a domain problem. Not for exponentials. They're fine. Their domain is -infinity to infinity. But logarithms, no. If you have a log of any base of a u, the domain is going to be u greater than 0 because the vertical asymptote is at u equals 0. The vertical asymptote is going to be at the 0. So whenever you have a logarithm of 0, the log does not exist and the vertical asymptote is there. The log does not exist and the vertical asymptote is there. Did you guys fill in the domain problem? Did you highlight it? Did you color pen it? Did you make it memorable? So what are the other domain problems from the year so far? Way back when in chapter 1. What's one domain problem? When can something not equal 0 besides logarithms? Way back when? Fractions, denominators. Good. So if you have a rational function, a denominator cannot equal 0. Good. That's a domain problem. What else? Square roots. Imaginary numbers are not real, right? They're complex. We can talk about them, but we can't really see them. So imaginary numbers. Underneath the square root, what has to be true? Greater than or equal to 0. If there's no fraction, if there's no logarithm, it can be 0. Just can't be negative. So domain problem number 1, denominators can't be 0. Domain problem number 2, arguments of a square root must be greater than or equal to 0. And domain problem number 3, logarithms. Argument must be greater than 0. Okay, thanks guys. We did not write that down. We needed to get it down. Let's come back to where we are though. We just did the example of ln of 1 over square root of e. That's negative 1/2. Easy cheesy. So what about this guy? Yeah, notes. Sorry, my bad. How many of you guys got negative 1/2 before me? We all got stuck? What got hard? Was it the 1/2? Was it the ln of 1? Oh, the negative, the quotient. Do we understand it now, though? Give me a thumbs up if you're like, yeah, negative 1/2, I get it. Okay. Doesn't mean you had the attitude if you put the thumbs up, but I understand if you're like, ugh, should have gotten that one. It's okay. After you practice some more in homework, hopefully you'll start mastering this skill better. And wait, why are we developing all these skills? Why are we trying to get better and better at playing with logarithms? Help us in the future because the hard puzzles are at the end, right? The more intense levels are coming. We won't be ready if we don't develop our skills first. In Fortnite, if you've never played it before, shouldn't you go do some free play? Maybe? Playground, whatever it's called, I don't know. Had some nieces and nephews, they're like, here you go. And I was like, oh my goodness. Yeah, I'm not a video game person. But I did get up to number 2. Yeah. And I was even moving around. I wasn't just hiding the whole time. Anyway. Right? If no one had ever played before, didn't have a clue, you probably would put them in the playground for a bit to kind of get used to everything, to build their whatevers. Play with the different weapons. Before just throwing them in the deep end and being like, here you go. All right, just a few of you wanted to start in section 3.6, but the rest of you guys, let's make our way through 3.1, 3.2, 3.3. So we'll be more than ready. Well, you'll still feel it a little bit, but you'll be adequately prepared to at least start tackling the problems at the end. All right, so developing the skill of expansion, expanding. Oh, this is super similar to what you just did, isn't it? It's just not going to be as pretty at the end. This one doesn't go down to a number. There's an X in there. We're going to be stuck. But what have you guys done? Good. And then what operation is after that? Because of the division. Good. And then? Okay, we can do it step by step. Of what? Okay. So rewrite the radical as a 1/2 with hopefully the intention of what? Power property, right? Now, just a few of you, and be careful if like a multiple choice answer was to have it one step further, would want to go one step further. But my question to you is the following. Is there a way to expand addition? What can you expand? Multiplication and division, that's it. You can expand multiplication, you can expand division, and you can simplify powers. Can you expand addition? No. Can you expand subtraction? No. What do you do with addition or subtraction? It's only a property if you're condensing. Good. It's only a property if you're condensing. Expanding only works with products and quotients and powers. So, what else? Nothing else. Dun, 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 dun. Nothing else. Robbie. I wish. I wish. It's killing the poor little puppy. And here's why. Robbie, old school calculators would have written the square root like this. It wouldn't have had the cool capabilities that your guys' newer calculators have of making it nice and pretty and over the numbers. See, we've written the square root first and then the x squared plus 1. What you're trying to do when you tell me, like, can't you? You're trying to say that this is really a multiply, and you're like, yay, I can take them to both. And I get why your brain is doing that. Because it's like, I can distribute anything I want. I can take a 2, I can take a 3, I can even bring power. Wait. This isn't multiply. It's not square root times. It's square root of. So even though the old school calculators had to write it like that, it's not times, it's of. And the struggle is, if I was to take the x squared plus 1, and if I was to try to find its zeros, its factors, I would end up with x plus I and x minus I. That's being square rooted because the negative 1 would have to be square rooted. It'd have to go imaginary. And even if I went imaginary for a little bit to factor it, they still aren't the same. So I cannot rewrite this as anything squared because it's not squared. So it's illegal to do. Does that make sense, kind of? Kyle?
Who's x minus 1? Wouldn't it be different?
Well, x squared minus 1, I wouldn't have to go imaginary to factor it, but still think of the factors. It'd be x plus 1, x minus 1. Is that anything squared? No. Still illegal, still killing a puppy. Tony? Sadly, think about your properties, but that's a very common mistake, Tony, and that's exactly what I was trying to warn you of. He sees the plus, and he's like, but we can pause and zoom in. What can we change with addition? Separate logs. So look at your example real quick. Single log. So the only thing we can do with single logs is expand them. We can't condense single logarithms. Does that make sense? Yeah, so we would need separate logarithms in order to legally be able to condense with addition or subtraction. But thank you so much for bringing that up. All right, whew, man, we must have so much left in this section because I took a whole nother day on it. Well, we're done. Okay, cool kids, who started and who got stuck somewhere? You can help out your class. Wait, I didn't start homework. Go to the back of your homework spiral. You can keep track of some questions, unless it was that easy. Anything? Tony? So those of you that haven't done homework or haven't gotten up to 17, go in the back of your homework spiral. You can record something that someone else thought was kind of tricky and have it ready to go when you get there tonight in homework. That sounds smart, right? Okay, so number 17, let me zoom in so that we can have a nice picture of it. That's my computer being sad and deleting all my shortcuts. 17, directions. Use properties of logarithms to rewrite and simplify. They didn't even tell me how. They just said rewrite and simplify. Little tricksters. I think we might have to pick out the clues from the problem itself as to what kind of rewriting. Guys, look at the problem. What do you think? Expanding or condensing? Why? It's a single log. Look at your properties if you need to. If your brain did not jump to expanding, look at your properties and say, oh, it's a single log. Okay. Can't I expand with like a subtraction-y thing? I'm going to show you guys another way of thinking about it that might be a little bit nicer, but for right now. Yeah, we can subtract. Log base 5 of 1 minus log base 5 of 250. Hey, what's any log of 1? Oh. 0 minus is just a negative. Okay, I'm done. Don't be done. Does your brain see what my brain sees? My brain sees a 25 and a 5, and those are kind of related when we're talking about powers, right? Does 5 go into 25? Yeah. How many times? Does 5 go into 250? Well, isn't that 25 and 10? And doesn't 10 have another 5? So how many 5s are in there? Oh, but there's also a 2. Huh, stinks. So am I stuck if I have log base 5 of 5 cubed times 2? Oh, I can't do anything. I really want to cancel out, but... Wait! Can't I use my property to expand and get rid of the 2? So I could go ahead and say, oh, that's negative log base 5 of 5 cubed. Oh, careful. This negative is for the whole logarithm, right? I'm about to put a plus, and that could get really dangerous if I don't put a parenthesis. I'm going to put plus, but that can get really dangerous. If this negative is supposed to be for this whole expression, I need the negative to go to both pieces of my sum. Okay, log base 5. Which one can I simplify? Yeah. What happens with log base 5 of 5 to the power of? What does log base 5 do to 5 to the power of? Undoes it. And what's left? 3. So I can say, oh, hey, that's the same thing as negative 3 plus log base 5 of 2. 2 is not a nice power of 5. So how are we going to finish it? Didn't I just distribute? Dun, 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 dun. That's what I would do, Tony. That's what I would do. If some of you guys are a little bit interested in how I mentioned a second ago, there is another way of considering this problem. Here's the other direction you could have gone, which doesn't really change a lot, but it does change a little. You could have made this 250 to the negative 1. Ooh. Negative exponent is from the denominator, right? So I just said 250 is to the negative 1 power, and what can you do with the negative 1 power? Oh, all it does is save me one step. All it does is save me the step of needing to remember that any log of 1 is 0. So, it's up to you guys. You could have thought of it as 250 to the negative 1. Negative 1 comes down. You still end up right here, and then just pick up where we left off. Both ways work. Both ways get you to the final solution. Or at least on the path to the right solution, I should say. That was number 17. That was Tony's question. Anybody else have one? They were like, Gavin. 32. Let's go check him out. Ooh, Andy's an even. Go team. I don't know what I'm hitting and what's opening right now. Go away. 30. Struggle. Got it. Find the exact value. That's their way of hinting that there might be a nice, pretty number answer, kind of like the one we started off with class today doing. 32. What do you guys think? Expanding or condensing? Yeah, right, Robbie? It's a single log. Good. So, can we rewrite anything? They're not the same yet. What do I have to do to signify the fourth root? Got it. Square root 1/2, cubed root 1/3, fourth root 1/4. Oh. There are two ways of doing this problem. I just need to take a vote real quick. I'm going to take the two different things that hopefully your brain is thinking. One of you, or one direction your brain can be going, is let's pull the 1/4 down, okay? One direction is let's pull the 1/4 down. The other direction is, oh, power to a power, you multiply. One is bringing it all together. One is taking it piece by piece. So pause. I just need to know, which one did your brain go to if it went to one? How many of you guys would say my brain's going to bringing it down? Okay. How many of you guys are my brain's going to power to power? Ooh, we're almost half and half. Okay. I'm going to go ahead and bring down just because that's probably the simpler way as far as the simpler steps. But power to a power, people, you're awesome because you're going to get to the exact same answer. Bringing down the 1/4 and quicker. Wait a minute, there's another power. What do we do with another power? Oh, let's bring him down. And you get the exact same thing as if you did power to a power, you multiply. Because you end up with 3 times, not plus 3 times 1/4. 3 times 1/4, well, ln of e is just 1. 3/4. Would have been the same thing if you had done 3 times the 4. 3 over 1 times 1 over 4. 3/4 up here and then brought it down. So you could either bring down piece by piece. You could even say something like ln of e cubed is 3. 3 times a 4th is 3/4. Many ways. But as long as you follow legal steps, you'll get there. 3/4. Cool. Anything else? Going once. Yeah, Pico. 65. Nice. 1 from the end. Ish. Ooh, it's getting exciting now. What? Hold on. They gave us some numeric approximations to use. I think they're trying to have us not use our calculator. Do you guys know that Mrs. Leon and Mr. Che have some very particular numbers memorized because they used to use them a lot or use them a lot in chemistry? Like, well, not even that though. They have decimal approximations memorized for square root of 2 and square root of 3 and square root of y. Because it helps them do the math quick if it's in a problem, and they see those numbers a lot. Guess what you could do with some with some basic logarithms? You could memorize, if you're going to see some certain logs over and over again, you could memorize some decimal equivalents. Now, this is kind of a weird problem, because this one, they actually don't tell you what the base is. So they're actually making it so that you can't just plug in the answer to your calculator. You have to understand the properties, which is kind of interesting. But maybe I gave you a little bit of practical application as to how or why you might have a few special numbers memorized, kind of like pi is 3.14, so we can kind of deal with it a little bit. Anyway, this one, they don't tell you what the base is, so you can't just go to your calculator. You have to break these logarithms down in terms of 2's and 3's and 5's. That's all we can do. Without 2's, 3's, and 5's, we won't have any clue of how to solve. Now, Vico, sorry, it was 65, right? Cool. 65. Don't stress about the clues. First stress, not even stress, think about how to rewrite. How can we rewrite 65? Expand or condense? There's a plus. Can we see that? What comes before the plus? Log base b of 3. What comes after the plus? Good. What can I do with the b squared? I can do 2 things. I can either bring down the 2, or I can just say log base b of b to the power of. The log undoes the b. What's left? The number 2. Well, I still don't know who... Oh. Dun, 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 dun. Almost done. Does that make sense? This is an entirely tricky section because they're forcing you to use the properties and not your calculator. That's actually kind of cool, though. That's actually kind of cool, though, because don't all of you guys have your calculator usually somewhat nearby in homework? And if they tell you something like, hey, solve it without your calculator, couldn't you kind of cheat and be like, but this one, there's no way to plug it in. That's fun. Okay, anything else? Going once. Going twice. All right, your goal tonight is to finish this homework by 7 a.m. tomorrow and get it posted in. Let's go ahead and start section 3.4. Whoo, look at the titles of this guy. I think we're starting to bring it all together. We focused on the exponential, guys, for 3.1. We introduced the basics of logarithms in 3.2. We said logarithms are kind of hard. Let's go over them a little bit more. In 3.3, And now, and now. It's time to start putting it all together in 3.4. And now, and now. It's time to start putting it all together in 3.4. So maybe we're just entering the playground, but we've been given a quick little tutorial on what all the different options, controls, weapons, etc. are. Maybe, just maybe, we're just entering the playground. Maybe, just maybe, we're starting with the easy Sudoku, just having kind of figured out the rules. As soon as you guys have this page written down, one person, every group, go back and grab a blue correction paper. Yeah, they ran out of white paper for a little bit, which is a bit of a party. They ran out of white paper for a little bit, but that's all right. We don't mind some blue paper, huh? Kind of makes it fun. All right, everybody's here. Adam and Aiden, glad you're back with us today. All right, any other groups that haven't yet gotten papers, go ahead and grab those now. Yeah, you can, the folder's not up there, huh? You can put it in the bottom tray of Honors Pre-Cal. I have to find the folder, I don't know where it went. It's a little weird. Okay, really quickly, let me get you guys your tests. That way you can get them back and you can get it filed away with that correction paper for you guys to work on for next week. Today is Thursday, so the deadline will be by next Thursday at the latest. We did the quick thing yesterday where we went on my website and reminded you guys of your different resources, right? Okay. Sorry, while it's loading, I'm getting things ready to save your notes online today. There we go. Honors Pre-Cal. I'm just looking at the calendar really fast because I don't want the deadline to coincide with something else as much as is possible. Ooh, next Thursday is the test. I don't want to go ahead and cram in corrections due the same day as a test. That's an awful idea. So instead, let's make these corrections due next Friday. I know that sounds weird, but do you guys know how you barely have any homework on test days, right? Just the reflection paper. Let's have it due next Friday. If you want to bust it out this weekend, turn it in on Monday. Like Kim actually got her test a little while ago, and so she's like, I have my corrections done. Because the day that you guys took the PSAT, I think they got their test back to do corrections on. So even though the folder is for some reason missing, oh, you know what? It's just in the wrong area. Nope, it's missing. Huh. Even though your guys' correction folder is missing, you can still just put it in this bottom tray where corrections go if at any point you finish these early. They're not going to be due until next Friday. That way it's not like stressing you guys out for the test. You can technically put it off until Thursday night. That's not smart, but it gives you a little extra time. Okay, come on up and grab your tests. Really quickly before you get them back, I went ahead and just showed whether you got full credit, aka nothing minused or subtracted on a multiple choice, half credit minus a half, or no credit, a complete X through a multiple choice question. You could have gotten all credit, half credit, or no credit on a multiple choice question, which is why when you guys see your score, you're going to see how many multiple choice you got wrong times 4.5, because that's how many points each multiple choice was worth. And then the long answer, I just took off points directly from 100. So the long answer, it's actual points taken off, and then the multiple choice, it's either the whole question or half of the question points being taken off. So you guys can check your scores that way, okay? Come on down. Robbie, here you go. Vico, here you go. Angelique, here you go. Johan, here you go. Update RenWeb today, guys, with these scores. I apologize. Usually I like you guys having your tests back before I update. And we kept on forgetting to give you your test back. We kept on forgetting to give you your test back. Tony, here you go. Austin, here you go. This was definitely a harder test for almost everybody. This was definitely a harder test for almost everybody. So take some time on these corrections. Oh, who was this? Wyatt, sorry. Take some time on these corrections. There were a few people that got A's. There were a couple that even got like hundreds. With some bonus, I don't think very many, if any, got absolutely nothing marked wrong. But there were some high scores, but the majority of you guys, this one hit you a little bit harder. This one hit you a little bit harder. Maybe you didn't have as much time to study. Maybe. There were some other issues. Maybe you didn't come in and ask for questions or help. Maybe you guys didn't reach out to your groups. There could have been a lot of different reasons as to why. I'll add it really quickly, and we're kind of passing back some papers. I do have some old reflections. They're just reflections. But I don't think I have that test reflections filed yet. So let me get that test reflections. Let me get that graded today. And then we'll pass back all the reflections tomorrow. That way you guys can kind of see what you thought about the test right away. That way you guys can see what you felt about the test right away and see if what your indication was, or kind of even where you're like, oh yeah, I should have studied this a little more, or maybe I should have spent a little more time on this. You guys can reflect a little bit better as to, well, how your reflection was. Gavin, what's up, bud? Number 8 was the extra bonus opportunity. That's true. For number 8, yes, you do need to correct it, because if you didn't get the points on it, it was technically something wrong, but you are allowed to use your calculator for corrections. Does that make sense? Should make it a lot easier. Some of you guys did get that double bonus, the bonus at the end and the bonus for number 8, which was pretty cool. But some of you guys, it was better that you just skipped it, and hopefully you did. Okay, go ahead and put away this test. Put away the correction paper. There are the possibilities, since this test did hit us pretty hard, there is the possibility, if you can get it correct with the correct work shown as to why the right answer is what it is, because I already gave you guys the right answers on the multiple choice. Long answer, you can ask your friends, you can come in and ask me if the right answer isn't written. There is the possibility you might get some partial credit back, aka points on the test. There is the possibility on this one, because it hits you a little bit harder than chapter 1. But you have to do your corrections well, okay? You have to figure out how to do it the right way. But you can use each other, you can use your book, you can use your notes, you can use me after school, you can use Mr. Che, who also teaches pre-cal. Use us. Don't go it alone, okay? Here we go. Section 3.4, test put away, correction papers put away. Let's get a little quick introduction to this section done, okay? Once again, putting it all together, taking all the skills that we've been building and saying, okay, what's the point? What are we supposed to be doing with these things? So, quick review. Whoa, my voice went something weird. One-to-one property. If we can make the bases match in exponential functions, yay! Logarithmic one-to-one property. If we can make log to the base match, yay! We can set them equal to each other. Inverse property. A to the will undo a log base A, and log base A will undo an A to the. These are all skills that we've been working on. So what was the point of these skills? Getting introduced to these types of functions, getting introduced to their main characteristics in equations and their main characteristics in graphs, even their domain problems if they have any, and learning some of the skills as far as how to break it down. Okay. What was the point? Well, to be able to solve equations. Like what? Like these. All right. Write them down. Let's start with A. We're going to bust through as many as we can because these are the easy ones. These are like the easy. In Sudoku, it wouldn't even be called easy. It'd be called super easy. Elementary easy. Baby kid easy. Okay. Now, hold on. Let's see what we can do. What do you guys think? Get rid of the 2 with a log base 2. Let's make the bases match. Anybody breaking down 32 yet? What would be really nice if they were all... Oh! How many 2's are there? Nice. So can't I just say 2 to the x is 2 to the 5th? So therefore, 1-to-1 property x is... If only they were all that easy. That's all right. Some of them are. We can use the 1-to-1 property. That's cool. That's cool. Letter B, 1-to-1. What? Oh. 1-to-1 property says there's 1 on either side. That's a great idea. If we add the ln of 3 to the other side, guys, we're just learning strategy now. Now it's just strategy. Kyle was like, I said sure, and why is that so nice? 1-to-1 property, what can I say? Nice. Although, I just say condensing. You couldn't use the quotient property. There is another way. So one way is not always the only way. We could have made it ln of x over 3. And do you guys remember how to get rid of an ln? What undoes a log base e? What if I do e to the power of both sides? So a little caret, e to the power of ln of x over 3, e to the power of 0. E to the ln just cancels out. Yeah, that's just x over 3. E to the 0, anything to the 0 is either way. Either way, whichever way your brain works, it could have gotten there. How about letter C? What do you guys think? Undo the 1/3 with log base 1/3? Maybe it's like this guy. I don't know about you guys, but doesn't this look a lot easier than 1/3? Ugh, how can I make the 1/3 into a 3? 3 to the negative 1. You can always make a 1 over into a power with a negative exponent. And why is that so great? Power to a power. Half of you were thinking about it earlier. Power to a power, what do? Multiply. So 3 to the negative x has to be 3 squared. So therefore, negative x has to equal 2. So therefore, x equals... So far, if you get really good at the skills, these 3 could have been mental math problems. If you get really good at the skills. There's no shame in showing work, and it's actually probably wiser and smarter to show work, but just letting you know. Speaking of mental math, how come I can go really quickly and say, oh, this one's easy, it's ln of 7. Ooh, how did I do that? How do I undo e? With an ln. What I do to one side, I do to the other. Ln of e cancels out to be x. Nice. That one, it wasn't enough to do 1-to-1. I could not make the 7 into an e to the power of. It was impossible. But I can undo the e with an ln. So use that idea. Oh, we almost got it. To undo these. What base would I do to both sides? 10 on this one, and which one on this one? You guys can go ahead and go, but this one is a mental math one of 81, 3 to the 4th. And this one's a mental math one of 1 over 10, 10 to the negative 1. But those are the basic ones, only 1 or 2 steps necessary. Tomorrow we got to get harder. Bye, guys.